The graph of 2x equals tan y is shown along with the tangent at x equals 0. The horizontal line y equals pi by 3 is also shown. We can see that one is this line just here. Using implicit differentiation, determine the equation of the tangent drawn at x equals 0. That's this line just here. So we know that 2x is equal to tan y. Differentiate both sides with respect to x. So that's 2. Now when you differentiate tan y, you get sec squared y, but remember we're differentiating with respect to x, so we need to multiply by dy dx. So dy dx is going to be 2 divided by sec squared y, but remember that sec y is equal to 1 over cos y, and so we can express that as 2 cos squared y. So if we want to evaluate that at the point of contact, which is the origin, so x equals 0, y equals 0, the cosine of y is therefore going to be the cosine of 0, which is 1, and so this is just going to be 2. And that tangent goes through the origin, and therefore the equation is y equals 2x. We're now asked to write an expression for the area of the shaded region. So let's just make some space and do it up here. So we want to find this shaded region just here. Now you could try to integrate that by using the x values and doing the integral of y dx. But I think that's actually quite awkward. Here, I'd be going the other way, integral of x dy. So if we think about that region, it's going to be the area trapped here with the curve, this one here, take away the area of the triangle, or if you like, the integral with the line. So we think about the line, which was y equals 2x. That means x equals y over 2. We think about the curve that we have, that is x is equal to a half tan y. And we know that this is 0 and this is pi by 3. So we're just going to have the integral from 0 to pi by 3 of the curve, so that's the area to the left of the curve, take away the area to the left of the line. And then in the final part of the question, we're asked to evaluate that integral. Now think about tan. Tan is sine over cos. The top is nearly the differential of the bottom. So if we have this situation, we now have the top as the differential of the bottom. So in other words, half tan y integrates to negative a half ln cos y. And then the y over 2 is just going to be y squared over 4. And we're going from 0 to pi by 3. So we have negative a half ln cos pi by 3 take away, substitute in pi by 3, and that's going to be pi squared over 3 squared, which is 9, and then we've got the 4 here, so that's going to be pi squared over 36. And with the 0, this is going to end up being 0 because cos of 0 is 1, log of 1 is 0, And of course, that will be 0 if we substitute 0 in. So we've just got a 0 there. So we have negative a half ln a half, take away pi squared on 36. Now remember that a half is 2 to the negative 1. Use a log law to move the negative 1 down in front. And what we get is a half ln 2, take away pi squared on 36.